So these are our current sets of Blueberry boards. These ones are already on, mounted, and matched together, but the cool thing about these boards is they have a connector on the back that they stack together. So this is a Blueberry main board. It has a Bluetooth low energy chip on it, an accelerometer, 2 switches or buttons, and then an RGB LED, and that's all for debugging and programming, and you can use those for pretty much whatever you want. And this other board is what's called a proto board, so it just breaks out all the signals that you can solder to easily on the Blueberries. And they orientate with these 3 little nubs on the PCBs at the top. So they stack together, and you can stack as many as you want to create whatever type of system you're trying to program or develop. And so anyway, that's the main board, and it communicates with all of the other main boards in the network, no matter how far apart they are. They relay messages to each other, and these also can communicate directly with iPhones or tablets, and then also cellular and Wi-Fi gateways. And so main board and proto board that you saw, this is the debug and development board, what we call the native dev board, and it has a plug to snap the main board in, or it can go at the bottom of the stack, and it also has a header to do the main programming of the Nordic chip that's on the main boards. We also have a spacer, so if you need more space between the boards than the standard connector has, you can put spacers in there. And this is what's called a breadboard adapter. So it's spaced to snap into a standard electronics breadboard and breaks out all the signals that are in the connector. So you can stack the Blueberries vertically like this, or we also have a spacer to stack them horizontally. So the main board can go in the center of the stack here, and then we can snap other boards on each side of it and go down into 3 different stacks. And then this is what we call the environment board. So it has an ambient light sensor, a humidity sensor, and a pressure sensor on there, and it also has a temperature sensor. So if you want to know anything about the environment, that's the board you would use. This board here is what's called just a motor board. So you can control up to 4 2-amp motors with it, and you can also stack up to 4 of these. So you can control 16 standard DC motors up to about 2 amps. And this board is the servo board, so it will control standard hobby servos using the power, ground, and signal lines. And you can also stack up to 4 of these, so you can have 16 servos on one main board. And because it's a mesh network, you can have as many main boards as you need in the system, and they all communicate. And they communicate over what's called a channel handle pair. So basically you set a number of what channel you want to communicate on, such as 1, 2, 3, 4, 5, all the way up to almost 50,000, and then you can send data with that channel, up to 14 bytes, and you can use that for whatever you want. This board is called basically the LiPo or power board. So you can plug in a standard LiPo cell here on the JST connector, and then it also has a micro USB connector for charging that LiPo, or you can directly power the Blueberry stack with that USB connector off of standard cable or some sort of USB power pack. And all of the power boards, whether it be these battery boards here, the CR2032 battery board, or this power board, we also have another power battery board that I'm developing. They all have an on-off button here, so that will actually turn everything on and off. And all of the signals are either broken out in the stack, or they're also on these castellated connectors on the edges. So you can solder directly to these signals. So the main board here has castellated connectors for each one of the switches, the RGB LEDs, and ground 3.3, VN, things like that. And this last board is a pretty fancy board. This is our IMU board, and it has a inertial measurement unit embedded onto this green circuit board here, And what's interesting about this particular IMU is that you actually get a quaternion out, so you don't have to do any of the sensor fusion yourself. So it has an accelerometer, a gyroscope, and a magnometer built into it, and you get a bearing vector directly out of it. So you don't have to do any of the sensor fusion yourself, and that's on the bus between the stacks. And then the last one here is the audio board, and it has a buzzer, piezo buzzer, that you can basically play things like old school Nintendo sounding things on it. And it also has an IR transceiver, so you can control it with a TV remote, or you can use it as a beam brake or proximity sensing or things like that. And then it also has a MEMS microphone, so you can do things off of sound events. And then we have 4 Blueberry stacks here on a CR32 battery board. So there's our main boards here, and I will get into this later, but these are set up for a demonstration. But you can see you can have as many as you want, and these will all communicate with each other. What else is interesting, is if you have 3, and let's say these are far apart, and this one can't directly talk to this one, it will relay messages through the berries in the middle, and that's basically what the mesh is. And so that whatever signal you send out with this one will broadcast to everything else in the mesh. And then I'll show a little demo of that next.